Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about recursion. To understand recursion better, it is required to have a good knowledge of function call stack. I have discussed function call stack in detail in previous video, so I highly recommend to watch previous video before you start this video. So let's get started. So first thing first, what is recursion? So let's first understand recursion through this real world analogy. I think the real world analogy is the best way to understand recursion. So let's say you are standing in a queue waiting for your turn to withdraw the money. And you are curious and you are getting late. So you want to know that how many people are standing in a queue in front of you. You have one option, and that is you step out of the queue and walk over the first person and start counting. 1, 2, 3, 4. And this way you got your answer that there are 3 persons standing in a queue in front of you. But you realize that I am doing a lot of work. How can I be too lazy? Because you are a lazy person and you like to do less work. So what you do? You just tap on the shoulder of the person standing in front of you and ask, what is your number? This person also do not know what the number is. So you ask this person, okay, do one thing, just call the person standing in front of you. So this person again tap on the shoulder of this person and ask, what is your number? This time this person also don't know what is the number of this person. So what this person does, so this person also taps on the shoulder of the person standing in front of him and ask, what is your number? Now this person is standing in the front of you, in front of ATM. So this person know that I am the first person in the queue. So this person responds back to the person standing behind it that I am the number 1. So this person got the response that, so if one person is standing in front of me means, and if I include myself, then it becomes 1 plus 1, means my number is 2. So this way this person calls the person standing back to him and he replies that I am number 2. So this person got the response that if he is number 2, then I must be number 3. And this way this idea travels to its actual asker, and the asker is you. Now you get the response from the person standing in front of you that I am 3. So you add 1 to it and you are the 4th person in the queue. So in this example we have seen 2 approaches. The first approach is you step out of the queue, run over to the ATM and start counting all the members one by one. So this is called an iterative approach. So we are solving a problem here, and the problem is I want to know how many members are standing in front of me, and we are doing iterative approach to solve this problem. And the second approach we have used in this example is a recursive approach. So in recursive approach, what we are doing, we are basically dividing our problem into sub-problems. I am a lazy person, so I do not want to solve the entire problem. So what I did, I just transfer the sub-problem to this person, and this person also transferred this small problem to this person, and this person has also transferred the problem to this person. And this way when the problem reaches to this person responds back to the caller, and this person also responds back to the caller, and this person also responds back to the caller. So this way we have divided the problem into smaller sub-problems and we got our answer, and that I am at the 4th position. So with this example we understood 2 things. First thing is we have to divide the problems into sub-problem, and the second thing is we need something where we need to stop. So in our case the stopping point is the first person. So this is going to be our stopping condition where our process gets completed, and after completion we get the response back. So I hope you understand the recursion used in the real life. Now let's move on to the definition of recursion. So what basically recursion is? So recursion is a way to write a program in which function calling smaller version of itself, right? So if I take this example again, so what is the function in this example? And that this person is tapping on the shoulder of this person and asking what is your number. This is our smaller function, and this function again calling smaller function on the other person. So in this example our smaller function is this. All right. So now the question is how we can use this idea of real world analogy and use it as a blueprint to model this in our programs. So to model this in our programs, we need exactly two things. And what is that? First of all, we need to find that what is the least amount of work I can do, right? So in our example, this person is lazy and he do not want to work more. So he thought of that what is the least amount of work I can do, and he simply tapped on, and what he did, he simply tapped on the shoulder of the person standing in front of him. So this is our first idea, that we want to calculate the least amount of the work I can do. And second thing, we want to know that what is the stopping point of our process. So we call this as a base condition also. So in recursion, we want to know two things. First, we want to know the least amount of work we can do, and we need a base condition or a stopping condition where we need to stop the process, right? So now let's understand this concept with an example, with a programming example. So let's say we have a problem, and the problem is really simple, that I want to print number from 1 to 5. So on the left side, you can see that this is an iterative approach. So there is a function print iteratively, and in this function, I am using a for loop. We initializing I with the n. We are checking if I is less than or equal to 5, and in each iteration we are incrementing I by 1. So when we call this function by passing 1 as an input parameter, this function gets called. When this function gets called, our loop starts executing. We first assign this n to I. So in our case, we are passing n equal to 1. So I gets assigned to 1. And then our loop checks if 1 is less than or equal to 5. The condition becomes true and 1 gets printed on the screen. And then 1 gets incremented by 1. And then I gets incremented by 1. And again the condition checks that if 2 is less than or equal to 5. So this process continues until we reach our condition. Which condition? When I become 6, this loop checks 6 less than or equal to 5. Our condition becomes false and our loop gets terminated. So this is how we get all the inputs on the screen. 1, 2, 3, 4, 5. So this is the iterative approach. Now, next we are going to convert this iterative approach into recursive approach. So here you can see the recursive approach of this problem. And the recursive approach of this function uses function call stack. So in iterative approach, you do not need to use the function call stack, but the recursive approach inherently uses function call stack to store the functions. So let's dry run this program and see how it works. So we have a function print recursively. So what we are doing in this function? So this is going to be our base condition. We talked about the base condition just before, right? So this is our base condition. So when n becomes 6, we want to stop our process. And other than that, what we are doing, we are just printing the number and we are calling ourselves with the smaller input, right? Or we can call ourselves with the larger input. Both can be true. Either you are reducing the size of n or either you are decreasing the size of n. So how this function is going to work? So when we run this program, our execution begins from the main function, right? So main is the function. So this function gets pushed into the call stack and the execution of this function begins. The next statement in this function call is again a function call, print recursively, and we are passing 1 as an input parameter to this function. So this is a function call. So this function also gets pushed into the function call stack, right? And the execution of this function begins from here. So right now our n is 1. So this condition is false. So our execution reaches to this point and it simply prints 1 on the screen. And the next thing we are doing here is we are again calling this function with the new parameter. okay, and that parameter is going to be 1 plus 1 2. So when we call this function again a function call, so it gets pushed into the call stack like this, and the execution again begins from here. Again we check n is equal to 6, this time n is 2, and this condition becomes false. So we simply print 2 onto the screen, and we call this function again with 2 plus 1 3 as an input parameter. So this way our function 2 calls, so this way our function 2 prints 2 and call itself with the parameter 3. So now this function prints 3 and call itself by increasing the input parameter by 1. Okay, now this function prints 4 and again call itself by increasing parameter by 1, and this function prints 5 and call itself by increasing parameter by 1. So this is where our recursion stops. Why? Because when we call a print function with the 6 as a parameter, we meet our base condition, and now our n is 6, so 6 is equal to 6. So when our base condition becomes true, we just return. We do not want to proceed. Our process gets completed here and we want to stop here. So this is our stopping point, right? So when we meet our condition, our print function 5 is waiting for print function 6 to get completed. So the print function 6 gives control back to the caller, and the caller is this function. If we look at this function, after this call we do not have anything to do. Okay, so that's why this function do not have anything to do after this call, so it returns control back to its caller, and same process continues to happen, and ultimately we get control back to our main function and our program stops running. So this is how this recursive program runs, and we get the output as 1 2 3 4 5. So if we observe both the programs and analyze how much work we are doing in iterative approach and recursive approach, we can see that in iterative approach, first work we are doing is initializing the I variable, then we are checking condition, then we are incrementing, and then we are printing. So how much work we are doing? 1 2 3 4. 4 work we are doing here. And if I consider the recursive approach, how much work we are doing? We are checking condition, we are printing, and we are just calling ourselves. So 3 work we are doing. So total number of work we are doing in iterative approach is 4, and total number of work we are doing in recursive approach is 3. So what do you think? Isn't it the recursive approach good enough to solve a problem? Because see, in recursive approach your code looks more cleaner than iterative approach, and also you are doing less amount of work in recursive approach than iterative approach. So this is a simple example, but you can imagine that there are more complex algorithms, more complex programs, lengthy programs. So in that case, if your problem is solved with the recursive approach, then you must go with it, because with recursive approach you get the smaller size of code, and also your code is more readable than the iterative approach. And when you use iterative approach, sometimes it gets really messy, right? And this problem can be solved using recursive approach. By using recursive approach, your code looks more elegant and cleaner. So now let's see some of the advantages or differences between recursion and iteration. So first of all, in recursion we have a base condition, and we stops our process when our base condition becomes true, while in iteration our for loop gets terminated when condition becomes false. So this is the difference, major difference. So this is the difference between recursion and iteration. Now we implement recursion using functions, while we implement iteration using for loops. Now in the recursion, as we are using function call stack, so for every call of the recursion function call, we need extra space in our call stack, right? But this is not the case in the iteration. We do not need any extra space to solve a problem using iteration. So this is a kind of trade-off you have to make. Either you want to save the space, or either you want to save time. So this is a kind of trade-off you have to. In recursion, you generally have a small code size, and in iteration you have a larger code size. We have seen recently that in recursion we are doing less amount of work as compared to iteration. So when you solve a problem using recursion, you generally write small code, and if you solve similar problem in iteration, you generally write larger code base. So there are many problems which is solved easily using the recursion. Like if you want to traverse non-linear data structure like trees, graph, then it is really easy to traverse those type of data structure using recursion. And if you want to traverse those kind of data structure in iteration, it is possible, but the code really becomes large and it becomes really messy. So we generally prefer recursion over iteration while solving those type of problems or while traversing non-linear data structures. So I hope now you have a clear understanding about recursion and what is the difference between iteration and recursion, what advantages recursion brings in terms of code complexity, and how problems can be solved very easily using recursion as compared to iteration. This is it for this video. Thanks for watching. See you in the next video.